What's up guys, Onmaths here, and today we're looking at further trigonometry. Now, what we mean by further trigonometry is anything that's trigonometry that's not to do with a right angle triangle. So we're not doing sine, cos and tan, SOHCAHTOA or any of that stuff. But we are going to be looking at a variety of questions that cover anything else to do with trigonometry. We've got one question related to the graphs, and then two questions related to the sine, cosine and the area rules. So looking at this question, this seems really like, oh my goodness, how am I going to do this straight away? Because we're looking for AD, and you might think, oh well, we've got a length and an angle, so we can just use SOHCAHTOA. Obviously we can't, because this angle is 90 degrees and isn't 90 degrees, and even if it was 90 degrees, we don't know this angle or this angle. So there's not enough information in the first triangle. So this triangle here, at the moment, doesn't have enough information for us to work out AD. Okay, and so what we've got to do is we've got to find out another piece of information about this triangle, because for the sine rule or the cosine rule to work, you need three known values in a triangle. So we've only got two here. We've got the 11.4 centimeters and the 86 degrees. So straight away we're looking at the other triangle. We're looking at this triangle here, and we're looking for this triangle to give us a piece of information about the other triangle, and the only thing that it can give us is the length of DB, which is this length here. So now we've got to ask ourselves, how do we find the length of DB? Okay, so this cosine rule and the sine rule, it's really important that you know which one to pick, because obviously it's going to be either the sine rule or the cosine rule, because we don't have a 90 degrees in the triangle, so it's not going to be SOHCAHTOA, and they're the only two rules that apply to non-right angle triangles that we know at this point. So the cosine rule relies on us having three lengths, so cosine is three lengths and one angle. Okay, one of those can be unknown, so one of the lengths can be unknown or the angle can be unknown. Here we've got an unknown length, we've got another known length, but we don't have the length here, so we can't possibly use the cosine rule. You need to have all three lengths and one angle for the cosine rule to apply. You could have like two angles obviously, or three angles, but you need to have at least one angle and just one of them being unknown. So here we've got two lengths that are unknown, so that's the cosine rule is not going to work. The other option is obviously the sine rule. Now the sine rule, we need two pairs of matching side and angles, and I'm trying to figure out a nice way of saying this: two pairs of opposite side and angles. Okay, so what I mean by that is, for the sine rule you need an angle, and then you need to know the length opposite it, and you need an angle and you need to know the length opposite it. Now one of those can be unknown, so either the angle or the length, but one of them can be unknown, but you need two pairs of opposite side and angle. Okay, and here that is true. The DB is unknown, which is fine because one of them can be unknown, but all the rest of them are paired up nicely. Now there's two flavours of the sine rule. There's one that you put the length on the top, and the other one you put the angles on the top. So the angles on the top look like this, so sine A over A equals sine B over B. Now this is really great when the angle's unknown. So use that formula when the angle's unknown. But here the length is unknown. So what we're going to do is we're just going to flip it. It just means that it's a bit easier to work out, because you have the unknown value at the top of the fraction rather than at the bottom. So what we're going to do here is we're going to substitute in the values. So we've got dB at the top. That's our unknown, and you could write x or y or something. You could put a letter in instead. Just make sure if you're going to do that that you label it on the diagram as x. So the A here is going to be the sibling of dB, the one opposite it. Okay, So looking at the diagram, the 34 is opposite it. And the other length we're using is the 12.5. And the sibling of that, the one opposite it, is 109. And don't forget, you only ever sine, cos or tan an angle. So the only thing that you'll ever sine, cos or tan will be an angle. You'll never do it to a length. Okay, so I'm going to do something to both sides. What we're going to do is we're going to times by sine 34 on both sides. And that will get rid of the sine 34 from the left hand side and just leave us with dB. So it will be sine 34 times 12.5 over sine 109. Okay, so we get our calculator out and we type that in. Now, whilst I'm doing this, this is really important that I remind you that whenever you click sine, cos or tan on the calculator, it will open a bracket. And especially if they're in a fraction, you must close that bracket. So if you typed in sine 34, it will look like that on the calculator. You must close that first, then write times. Then when you do the sine 109, it will put another bracket in. You must close that one, otherwise you'll get a syntax error or maths error or something. Okay, so we get 7.392674744. Now, the reason I'm writing it all down and not rounding it is because it's not an answer, and you should never round numbers that aren't answers, otherwise it can throw your answer off quite dramatically. So I always just write down the entire calculator display, and so in case I lose it in my calculator, I can have a similar accuracy. They're quite forgiving in the exam though. So if you do round it to the first 2 decimal places or something, normally they'll give you the benefit of the doubt and they'll let you get the full marks, but I try not to test that. Okay, so now we know what dB is, we've got to look at the blue triangle and figure out how we're going to work out AD. So this is our unknown now. We do know dB now, and I can even write that in 7.39 blah blah blah. Okay, so we're looking back at our sine and cosine judgments. We only have one angle in this triangle, so we can't possibly get 2 pairs of opposite sides and angles even if we tried. There's just not enough information for that. But what we do have now is we have 3 lengths and 1 angle, which was the caveat of the cosine rule. So you need 3 lengths, 1 angle, one of them being unknown. Well, in this case, one of the lengths is unknown, so we've labelled it AD. Okay, so this is definitely the cosine rule. So we write out the cosine rule, which is a squared, and in fact let's do that in blue. A squared equals b squared plus c squared minus 2bc cos A. Almost wrote sine for some reason. Right. The one you're trying to find, the length you're trying to find, if it is a length, and we'll talk about angles maybe later, the length you're trying to find will be labelled the A. Okay, so that's going to be the AD. The B and C are just not important. As long, even if you're not consistent with what you're labelling B and C, as long as they're the other 2 angles, if you look here, we're adding them together, and here we're timesing them. It doesn't matter which way around we have them. So we have let's do the 7.39 blah 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 first, because then it's easier because it's in our calculator already. I might have to do another line here in a sec. And that's not great, but because I've zoomed in, I've kind of run out of space. Okay, so let's type that into our calculator. And we're going to have to type the 7.39 again a later bit. And you can use the memory function on your calculator as well. Okay, so we've got 172.853978 blah blah blah. Okay, the problem is that this is AD squared. So if I just put a quick lines in, we know that to find out AD, we just square root both sides. Now, what you can do in your calculator is you can just type in the square root button and then the answer button, which are in the Casio calculators are right at the bottom, and it will just square root the previous answer. Saves you having to write it all out again. And that gives us the answer of 13.14739 blah blah blah. And it says it wants it to 3 significant figures, so 13.1 to 3 significant figures. And let's just see if there's an answer bit here. Okay, last thing I would do is just check that these are reasonable. So that's pretty much 90 degrees. 86 degrees is pretty much 90 degrees. It's not quite. So I would expect AD to be the longest length in that triangle because it almost is a right angle triangle. And so 13.1 is kind of what I would expect AD to be. So just use your common sense. If you're getting 0.0013 or something, it just flags it up. Right, I'm going to have to check my working out on that. So it's always best just to kind of check that that your answer's within what you would expect. Doesn't mean it's wrong if it's outside of what you'd expect. It just means that maybe that's the question you go back to at the end of the paper. Okay, we're going to have a bit of a change of pace with this AQA question now. Now this is testing our knowledge about what the trigonometric graphs look like, and it has the cosine graph here, and it actually draws it out for you, which is kind. They kind of didn't need to for this question. I think it's because it's only, was it a 2-mark question, that they probably didn't have enough marks left in the paper to award you marks for knowing what the graph looks like, but you do have to know for the exam. So this is saying that we've got a value which I'm going to call A. It's an alpha, but I'm going to call it A on the x-axis, and on the y-axis that gives you K. So A leads to K. So A is an angle, and then K is what happens when you cosine that angle, okay? And here it says, well, okay, so what's the value, in terms of K, what's the value of cos 180 minus A? So if we go to 180 and we take away A, and this is kind of rough, but it will be about here, okay? So I've done the same thing as they've done, but the thing they're testing you here on is that you know that these graphs are completely symmetrical. So if I have the value here, and I've gone a little bit far, so let's kind of back up a little bit. So I think I've gone a little bit far, even though it's not drawn to scale, I know that. But so if we go down from there, that point there where it crosses is going to be 180 minus A. Okay. Now the point that they're making here, and the point that you should know, is they're completely symmetrical. Like there's a lot of symmetry in here. I say completely symmetrical. If it was completely symmetrical, it would look like that. But there's symmetry all the way through this. So if the A part here gave you K, then 180 minus A, which is this point here, will be the same value as K, but negative. Okay, because of all the symmetry that goes on with the cosine and sine waves, and to a certain degree the tan, although tan gets a bit weird. So it's going to be the same value of K, but negative. Similarly, with the question B, it's testing that you understand that these go on forever. They just keep looping. And what we've got in the diagram here is one complete cycle, or one period. And you need to know that the graph doesn't just stop there, it just keeps going on and on and on forever. Okay, so if we add 360 to A, it's going to be from the 360, it's going to go here. And that's just going to give you the same value. It's just going to be K again. Now, just if you don't quite understand the answers to these questions, my massive recommendation is just sit down and just work through them. You'll see all the symmetry, and there's a complete symmetry around 180 degrees, on the range of 0 to 360. So if you've got a value on the left of the 180 degree line, you can easily find out the value on the right of it. And yeah, just understanding the symmetry that is in a cosine and sine wave is going to be really important for your exam. Last up is our OCR question, and I like questions that look really easy. This question looks so easy. It doesn't look like it's going to challenge us at all, and yet it really is not. So we're asked for the area of the triangle, and one of the temptations might be to draw a line down here, try and work out that length there, and then work out the areas of the triangles to the left and right by using half base times height. There is kind of a way of doing that, but the rules we use are nothing to do with drawing that line. We're going to use either the sine or the cosine rule, which we'll talk about in a second, and then we're going to use the area rule, which is half AB sine C. Now that area rule is derivative of drawing a line down the middle, but it's a much easier way of getting there, which we're not going to go into where the rules come from, because that's more kind of A-level stuff, but it's important to note that theoretically you could get it through that method, but you would have trouble. So what we've got to figure out is the fact that when you've got a non-right angled triangle, especially at this point of the paper, so question 18, probably it's going to be the area rule. So to work out the area, as I said before, we need half AB sine C. Now working backwards from the formula, we know that we need two lengths, A and B, and an angle. We need to have that. It's not like one of them can be unknown. No, we need the angle. Here we're not given an angle, so we need to find an angle. Now, because it doesn't really matter which angle you pick at all, because you can just rotate this triangle and just pick any angle. I'm going to pick this one here. Why? Well, because it's at the bottom left. That is the only reason I'm picking that one. This method would work any of the three angles. It would be exactly the same answer. The working out would be different, like along the way. Obviously, the angle will be different, but then it will still generate the same answer. Because if I picked this one, the A and the B would be different. The A and the B would be 6.4 and 3.9, and that would make the answer correct, even though the angle is different. Okay, so we know we need to find an angle for this, and that's the first really important step that you realise with this question. The next thing we need to figure out is how we're going to do it. Well, what have we got here? We've got three lengths, and an angle. Okay, and whenever we have three lengths and an angle, looking at question 1 that we just went through, we know that's going to be the cosine rule. Okay, so the cosine rule is written out as this. Which we did before. But that doesn't help us at all, because we're looking for the angle. So you might want to learn what we're going to do. You might want to learn this, but we're just going to rearrange this. And we're going to add 2bc cos A. And I've got enough C's there. Okay, so we've got A squared plus 2bc cos A, and we've just got the b squared plus c squared. Then we're going to take away the a squared. So we've got 2bc cos A equals b squared plus c squared minus a squared. And I never do these lines long enough. Always optimistic. I can get it done quicker. Then we're going to divide out. We're going to divide out the 2bc. So we're left with cos A equals b squared plus c squared minus a squared over 2bc. Now, what a lot of teachers ask you to do is learn that formula. So obviously you've got to learn this formula, but to learn the cos A formula, just because when you go through the rearranging, which I've just done, you might make a mistake. So just learn both formulas. So therefore, you know how to work out sine for angles and lengths, and if you know both these formulas, you know how to work out lengths and angles for the cosine rule. If you forget, if you only know the a squared one, that's how you work out the angle one. And you can just substitute straight into the a squared one and rearrange it after you've substituted. That's absolutely fine to do as well. Okay, so we're going to now use this formula to work out the angle. And I'm just maybe going to call the angle A, just because it's easier. So we've got cos A equals... Okay, now B and C don't matter. Doesn't matter which way around, as long as it's these ones. The little a must be the one opposite the angle you're working out. Okay, it has to be. So we've got b squared, I don't know, 5.8 plus c squared 6.4 minus, and this must be 3.9 if we pick this angle. Okay, over 2 times, and it doesn't matter which way around we have these, because when you multiply, it doesn't matter. Okay, let's put that into our calculator. Okay, so I'd recommend you put that into a fraction on the calculator, because sometimes if you try it with divide, you'll need to put brackets around the top and bottom, and you might make a mistake. And if you do it as a fraction on most calculators, you get a fraction out, which is always good, because it means not much writing down. Okay, so this is cos A equals. So the last thing we need to do is get our lines down. We need to inverse cos both sides. So that we get A equals inverse cos of 5939 over 7424. Okay, and what you can do on your calculator is just type in inverse cos, second function cos, answer, and then close the brackets. And we get 36.87247012, blah blah blah. Okay, let's just tidy this up. So we know this angle is 36.87 blah blah blah. And then we just go back to the area formula we talked about earlier, and now we know that piece, we just put it into the equation. So it's half A, and A and B are the lengths that aren't opposite the angle. Okay, so they are this one and this one. Okay, and it's really important for the area formula that they're not opposite the angle. So 5.8 times 6.4 times sine, and then 36.87 blah blah blah. Okay, so what I would do is, the first thing I'll do is sign my answer and kind of do this bit first, just so that I can keep it, the precision, absolutely perfect. So sign answer, and then I type in times 6.4 times 5.8 times a half, or just 0.5. And that gives me, that gives me 11.136666. How many sixes? 4 6s and a 4. Okay, so the last thing we need to do really is round it, and if it doesn't say in the question, which it doesn't, I'd just pick 3 significant figures. So 11.1 to 3 significant figures. And that's our answer. So sorry about the slightly longer video. I was hoping that the second question would cut down time a little bit, but still it's almost half an hour. So I hope you found that video useful. If you did, please click like. If you want to see more from us, we're releasing videos every single weekday at 9 o'clock in the morning. So just click subscribe and the bell icon to make sure you're up to date with all the videos we release. We are going to come to an end soon, so please keep your comments coming in about ideas of stuff you want us to cover after summer school's finished. It's already finished for foundation, but we've got a few more topics left for the higher tier. If you haven't already, which I'm sure you have, you can check out our website onmaths.com by clicking the link that magically appears at the top. It will take you straight there. It's packed full of completely free resources to help you with your maths. Otherwise, thank you very much, and I'll see you tomorrow.